Welcome, everyone. Today we are looking into constraint-based engineering. We will learn how applying strict boundaries, like negative constraints, forces Claude out of its comfort zone to generate incredibly original, high-quality outputs. Let's get started. Let's introduce constraint-based engineering. Instead of just telling the AI what to do, we intentionally limit its options. Why? Because LLMs naturally take the path of least resistance, giving you generic, predictable text. By establishing boundaries, we create productive friction, forcing Claude to dig deeper for novel insights. Look at this comparison. A standard prompt takes the upper path, leading directly to generic output. But the lower path shows our approach. Adding constraints introduces creative friction. This friction acts as a filter, forcing the AI to generate high-quality, novel output instead of taking the easy way out. Now let's explore negative constraints. Corporate buzzwords like efficient or leverage are high-probability words for an AI. If you explicitly ban them, Claude can't hide behind jargon. It is mathematically forced to use lower probability, highly descriptive words, drastically improving the depth and clarity of the text. This decision tree shows the cognitive shift in the AI. We start with a concept like speed. Without constraints, the AI defaults to the buzzword efficient. But with a negative constraint, do not use efficient, it is routed to the right, forced to explain the actual mechanics, yielding a precise phrase like minimizes wasted clock cycles. Next is the impossible constraint challenge. We intentionally apply severe, seemingly absurd limitations. Ask the AI to solve a problem with zero budget and no internet. This shatters the model's standard assumptions, forcing it to look past obvious solutions like run social media ads and discover truly innovative, lateral approaches. This mind map contrasts standard problem-solving with our impossible constraints methodology. At the top, standard solutions rely on typical resources like ad spend. But by branching into impossible constraints, cutting off budgets and internet, the AI is forced to generate entirely different nodes, like grassroots networking and utilizing existing assets. Our fourth technique is the cascading constraint system. Here, you iteratively tighten the rules. You ask Claude for a 500-word explanation, then constrain it to 100 words, then one sentence, and finally, a single metaphor. By forcing this cascade, you strip away all the fluff, leaving only the pure, unshakable core insight. Here is the cascade in action, visualized as a funnel. The raw idea starts at pass 1 with 500 words. As it moves down through the passes, the constraints become exponentially tighter. By the time it reaches pass 4, reduced to just a single metaphor, it emerges at the bottom as a polished, core creative insight. It is crucial to distinguish between semantic and structural constraints. Negative constraints are perfect for semantic-spanning words to boost creativity. But for formatting, use positive constraints. Instead of saying do not use markdown, explicitly say format as smoothly flowing prose. Tell the AI what shape to make and what words to avoid. This split diagram highlights the optimal approach for prompt engineering. On the left, we apply negative semantic constraints, which drive the model toward creative thought. On the right, we apply positive structural constraints, dictating the exact shape of the output to guarantee a clean format. Beware the over-constraining pitfall. If you apply too many conflicting rules, the AI experiences constraint confusion. It will prioritize satisfying your impossible formatting rules over factual accuracy, leading to hallucinations or task failure. Relevant specificity is great, but contradictory boundaries break the system. This state diagram maps the danger zone. We begin safely in the balanced state, which reliably produces high-quality output. However, adding conflicting rules pushes the system into the over-constrained state, inevitably leading to task failure and hallucinations. To recover, we must simplify the constraints and return to balance. Let's apply this to a real-time use case, the strategy reframe. A consultant needs a turnaround plan but knows AI defaults to corporate fluff. They prompt Claude, draft a strategy. You may not use synergy, leverage, optimize, or efficient. Stripped of its buzzwords, Claude is forced to describe concrete, physical actions, delivering a highly actionable and human operational plan. This sequence diagram illustrates the transaction. The user sends the task, wrapped in a strict negative constraint. The note over Claude indicates the internal mechanism. The model actively discards its high-probability corporate buzzwords. It then returns the payload to the user as a specific, actionable operational plan. To summarize, constraint-based engineering forces deep AI reasoning by blocking the easy answers. Ban the buzzwords, use impossible constraints to spark innovation, and never over-constrain the model. Thank you for joining. I highly invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final roadmap shows the path to mastery. You set your goal, apply negative constraints to force deep reasoning, perform iterative refinement, and carefully verify the output. The final and most important step to accelerate your learning, visit quicktechie.com.